what type of calibration is actually made and the types of thermometers we generally use. So what are the types of thermometers we use in general, children? The types of thermometer we come across is, first one is all about your Celsius scale. Next is all Fahrenheit scale. Kelvin scale. Römer scale. Rankine scale, and many more are there. So let us try to discuss them in detail. So first of all, Celsius scale. So as I have discussed just now that every scale is having one lower fixed point, the other upper fixed point. So let us discuss about these scales in detail. Here we go. So let us look into the details of these scales in detail. So first of all regarding your Celsius scale. First one, Celsius scale. The name itself indicates that Celsius scale was designed by the person named Andreas Celsius in the year 1910. In the year 1910. Okay. So, this Celsius scale, the lower fixed point is taken as, in the Celsius scale, the lower fixed point is taken as 0 degree Celsius, whereas the upper fixed point is taken as 100 degree Celsius. Okay, children? So, the intervals between these 100 and 0 is intervals. 100 minus 0, that is equals to 100. So, we have 100 markings between this LFP as well as UFP. And each marking is having a length of 1 degree Celsius. The marking on the scale is of every 1 degree Celsius, the next reading will be taken. So, it is having 100 intervals. And the total length of this scale is given as, the total length of the scale is given as 100. Okay. So, now, depending upon that, the construction can be done. So, each interval is of about 1 degree Celsius. The other name for Celsius scale, it can also be called as your centigrade scale. It is also called as your centigrade scale or Celsius scale. Both means the same. Okay. That means every part of this consists of about 1 by 100. Okay. So, a degree on a Celsius scale. What is that? A degree on a Celsius scale is around 1 by 100th part. How much, children? 1 by 100th part of the interval between the lower fixed point and the upper fixed point. So, this is all about your Celsius scale. Now, moving to the Fahrenheit scale. The next one is all about your Fahrenheit scale. This Fahrenheit scale was invented by the person named Gabriel Fahrenheit. In the year 1717. In the year 1717. And the lower fixed point for this Fahrenheit scale is taken as 32 degree F. The lower fixed point is taken as 32 degree F, whereas the upper fixed point is taken as 212 Fahrenheit. 212 degree F. Okay. So, what is the length or interval? The length of the scale is around 212 minus 32 and it is equals to 180. Okay. So, how many intervals are there? Number of intervals on this scale will be, we have 180 intervals. Okay. And the value of 1 degree Fahrenheit corresponds to 1 by 180th part of the intervals between low FP and this UFP. So, between the lower fixed point and the upper fixed point, how many intervals are there, children? 1 by 180th, 180 intervals are there. So, each Fahrenheit corresponds to 1 by 180 part of the total intervals between the lower fixed point as well as your upper fixed point. Now moving to the next one, that is all about your Kelvin scale. So the next one is Kelvin scale. So the name itself indicates that the Kelvin scale was invented by the person Lord Kelvin during the year, so unknown, so 1824, something like this person exists to be 1824 and 1907, and this lower fixed point of this Kelvin scale, it consists of the low LFP is marked as 273 Kelvin. Lower fixed point is marked as 273 Kelvin and upper fixed point is marked as 373 Kelvin. Hence, the number of intervals for this is 373 minus 273 is 100 intervals. Okay. So, 100 intervals. So, the length of the scale is around 100. And the every 1 degree Kelvin corresponds to 1 by 100th part of the reading between the LFP as well as your UFP. So, as it is divided into 100 equal parts, so each Kelvin corresponds to the 1 by 100th part of the total readings. Now, moving to the next one, that is all about your Römer scale. Okay. So, this scale was indicated by the person named R.A. Römer during the period something like 1730. Okay. In this scale, the lower fixed point is marked as 0 R, whereas upper fixed point is marked as 80 R, where R indicates the Römer scale. So, degree F, here 273K and 373K. Similarly, here 0 R as well as 80 R. So, the intervals between, the number of intervals between in this scale is 80 minus 0 and that is found to be 80. That means 1 Römer corresponds to a part of 1 by 80th part of the total readings between LFP as well as UFP. So, this is all about your types of thermometric scales. Now, let us try to discuss the relation between all these Römers, all the scales that we have, whatever we have discussed till far. Okay. So, to understand you clearly, let us revise back once again regarding the thermometer. So, this is how the thermometer looks like. So, this is your glass bulb in which mercury is being kept, and this is a thick glass on which, inside which a narrow bore will be there, and inside this narrow bore the thermometric liquid starts expanding, and this is being calibrated something like this. Readings on this is given. On this reading, this corresponds to the LFP, lower fixed point, and here corresponds to the UFP, upper fixed points. Depending on the scale, the number of intervals are divided and then the reading will be marked. So, let us discuss in detail regarding the relation between all these scales. This only plays the major role in solving our numerical. So, children, Focus on this very carefully. So, relation between the different thermometric scales, very, very, very important. Relation between different thermometric scales. First one, let us discuss in detail regarding the Celsius scale. So, Celsius scale indicated with the letter C. Next, Fahrenheit scale with the letter F. Kelvin scale with the letter K, whereas the Römer scale indicated with the letter R. Okay. Let us recall back the lower fixed point of the Celsius scale indicated with the letter 0, whereas upper fixed point is 0 and 2 upper fixed point is 100. It's a calibration. In the Fahrenheit scale, it is starts from 32, ends at 212. For Kelvin scale, starts at 273 as well as ends at 373, and Römer scale starts at 0 and ends at 80. Children, remember that Kelvin scale is also called as absolute scale of temperature. Celsius scale or centigrade scale, Kelvin scale or absolute scale. Why it is called as absolute scale means, suppose for 273 Kelvin, okay, if you add minus 273 Kelvin, then how much it will be? 0 degree. The value will be 0. Okay, and this is taken as your melting point of ice, absolute 0. So, in order to convert the Kelvin square to a lower fixed point on a Celsius scale, you have to add up it minus 273 Kelvin. Okay, so this is also and gives you absolute 0. So, absolute scale also it is been given. In order to find the relation between all these things, one simple formula you have to remember, children. Thermometric reading. What is that? Thermometric reading, whether C, F, K, R indicates your thermometric reading minus LFP, lower fixed point, upon UFP, upper fixed point, minus LFP, lower fixed point, always remains constant. So, this is the most important formula you need to remember, children. So, what is that? Thermometric reading minus LFP upon UFP minus LFP is always constant. So, using this, let us discuss in detail regarding them. So, first of all, let us compare for thermometric reading on the Celsius scale, some C let us indicate, minus UFP is 0 upon LFP is 0, 100 minus 0 must be equals to constant, means its value always remains some value. How much is that means? If you compare with the Fahrenheit scale, thermometric reading indicated by F, minus LFP is 32 upon UFP is 212 minus 32. Always gives equal value. So, thermometric scale minus LFP upon UFP minus LFP always remains constant. This can be comparable with the Kelvin scale. So, Kelvin scale let us indicate with K, minus LFP is 273 upon UFP is 373 minus LFP 273 can also be compared with the Römer scale as, so in Römer scale R minus 0 upon 80 minus 0. So this always gives a constant value. Simplifying further, C minus 0 gives C, 100 minus 0 gives 100 equals to F minus 32 upon 212 minus 30 equals to 180 equals to K minus 273 upon 373 minus 273 is taken as 100 equals to R minus 0 is R upon 80. So simplifying further, we have the zeros gets cancelled. And now this goes 5 times, 9 times, 5 times as well as 4 times. So rewriting the above relation, we have C upon 5 is equals to F minus 32 upon 9 equals to K minus 273 upon 5 must be equals to R by 4. So this is the most important relation. So if you are clear with this formula, you can solve as many numericals as possible. And one more thing, remember children, so generally while constructing a thermometer, some faulty thermometers can be made. Okay, there may be some errors while constructing a thermometer, maybe 1 degree or 2 degree or something like that. So faulty thermometer always gives a wrong reading. So there are numericals based on that, which we have to correct it. Okay. So now, just if you are thorough with these formulas and the concept, let us move to the numerical part of this thermometry concept.